On proof 38, I'll start by marking what I know. I know that LF is congruent to KF, and I know that LA is congruent to KA. Now, what I'm trying to prove is that LJ is congruent to JK. Now, those two parts are along these two small triangles, where I notice that I have angle 1 and angle 2 already listed, but no given information about it. So I'm thinking that I'll probably need to use angle 1 and angle 2. My plan of attack is to show that these two purple triangles are congruent, and then use CPCTC to take the parts that I want. So as I begin to mark things on those two purple triangles, I notice right away that FJ would be reflexive to itself. It's in both of those triangles. So I already have a side and a side, and what I'm seeing is that angle 1 and angle 2 would finish off a nice side angle side relationship. So what I'm looking for is a reason to say that 1 and 2 are congruent. I don't see any linear pairs, they're not vertical angles, and then I notice that LA and KA was given to me, but it's nowhere near what I'm looking at. So what that tells me is that it's probably going to be that two other triangles are congruent that I can then use to get angle 1 and angle 2 also congruent. So I'm going to look for two triangles that have angle 1 and angle 2 in them and already have some information. And the two triangles that I see would be triangle FLA, which has angle 1 over here, so FLA, and I'm seeing triangle FKA directly underneath that. And that triangle has angle 2 right over here. So going back to my given information, FL and FK were already given, LA and KA were already given, and now I see it. FA is reflexive to itself FA, so I have a side-side-side relationship here. And if those two triangles are congruent by side-side-side, then that means angle 1 and angle 2 are the same by CPCTC. And if angle 1 and angle 2 are the same, then I've got my side angle side relationship that I wanted, which means those two purple triangles are congruent, which means I can grab the sides here by CPCTC. So there's my explanation and my reasoning. Now I got to make sure that I write all that correctly. So I have LF was congruent to KF, and LA is congruent to KA because that was given to me. And then the very next thing that I marked was the reflexive side of F to J. So FJ was congruent to FJ because it was reflexive. Well, I also marked later on that FA was congruent to FA by the reflexive property. So rather than write it in two different steps, I'll just list all the reflexive pieces that I used as statement number 2. Once I marked that FA was reflexive to itself, that's what led me to the side-side-side relationship. So my next statement is going to be that triangle FLA is in fact congruent to triangle FKA by the side-side-side. And again, I'm going to go ahead and slow down and say if I'm using side-side-side, I better have all of those sides listed. LF to KF was one of the sides. LA congruent to KA was a second pair of sides, and it was FA to FA that was the third pair of sides that allowed me to say that side-side-side relationship. The whole goal of me using that congruent triangles was so I could grab the parts of angle 1 and angle 2 being congruent by CPCTC, because then once I had those, I was able to say that these two small triangles, LFJ and triangle KFJ, are congruent because of a side angle side relationship. And here again I'm going to stop and I'm going to double check and make sure I listed all that. The first pair of sides in that would be FL. So I'm using this pair of sides again, but it is listed in my proof. I'm using side FJ, so that was listed right here in my proof under the reflexive. And then I used angle 1 and angle 2, which is the statement number 4 that I just finished writing. So I do have my side, my angle, and my side that I'm using listed in the proof, which means I can make that congruency statement. So I can finish by saying, you know what, if those triangles are congruent, then LJ has to be congruent to KJ because of the corresponding parts of those two congruent triangles are congruent, so CP, CTC.